All right, we'll get started. It's 12 o'clock, and we appreciate everybody joining us as always. And for our web audience that's out there too, thanks for joining in. And just our couple quick intro slides like we always do, and then we'll turn it over to our guest speakers. So first off, future user group dates. And this is hard to believe that we only got 3 topics left in 2019. The year is that close to being over with. So next month we'll do drives update with PowerFlex 6000 medium voltage drive. October we're going to touch on machine safety. No session in November since it's Automation Fair, and then in December we'll wrap it up with a best in show 4 as we call it. So kind of the best takeaways from the Automation Fair. And then of course 2020 dates, they'll be forthcoming. We starting to put the schedule together and get some topics going. So today's topic is ProSoft, and it was kind of funny, we were talking before the session started, and our last ProSoft related topic was going way back to September 2015, and we touched on the phase legacy network migration solution. So that's a great session, and it was recorded, and we have it available on our archive. So invite everybody to go back in time to that session and learn more about the migration solutions. And then one last slide is just to plug away at the Automation Fair. So again, that's coming up soon, November 20th and 21st. It's in Chicago this year. Our guest speakers will be in Chicago, I believe, and as well as all of us from the Reynolds team. And we do have travel packages coming soon, so details on that very soon from your account managers. So we invite everybody to Chicago. And with that, we're going to turn it over to ProSoft and let them present. Just a quick introduction. Joe Dara from ProSoft is here in the room live, and Eric Syme is also here in the room live, and I'll let they can introduce themselves and their roles real quick as we switch the presenters over. I'll let you grab it.
Yeah, no problem. Good afternoon, everyone. My name is Joe Dara. I am the new ProSoft Regional Sales Manager or Account Territory Manager. I am based in Dallas. I support Texas, Louisiana, and Arkansas. So if you have any ProSoft needs, Eric and I will be available not only today, but please feel free to reach out to us. I have some business cards here, and we'll put my contact information up at the end. Feel free to reach out via email or phone. Thank you.
All right, and hello, my name is Eric Syme. I'm a Director of Program Management with ProSoft Technology. So I work with customers and our engineering team to kind of fulfill application requirements. And so thanks for having me out here today. I'm based out of Denver, Colorado. Used to be based out of our headquarters that's in Bakersfield, California, but moved over to Denver about 2.5 years ago. So quick flight over here. But today we're going to talk about leveraging IIoT, and mainly tied to our cloud-based products, some data logging or data acquisition product that we have, as well as our in-chassis flow computer. And so just a quick introduction on ProSoft. We're historically known as kind of the Modbus guys. We started out doing Modbus modules for PLC5s back in the 90s with Rockwell. We're one of the first Encompass partners. I think we're approaching 30 years now or something like that. But really, Modbus is still a key component for us. We still keep sticking around. I know 10 years ago we had discussion about Modbus going away, and it's still out there in the field and in use today. But really, we are a lot more than just a Modbus company, and when we start talking about some of the IIoT solutions, really Modbus can be a component of that. Data acquisition is a key thing for enabling smart devices and getting information in the proper locations so you can make intelligent business decisions. But we also have some other products that kind of help out with that just a little bit more. We also have solutions for wireless applications, as well as modernization solutions is another key focus area for us. So we've got a broad spectrum of products, everything from modules that slide directly into the Rockwell chassis, so control logics, compact logics, point IO modules. We've got standalone gateways that basically DIN rail mount communication solutions, and then a full range of industrial wireless solutions. Everything from 802.11 to industrial cellular applications as well. So as far as some of our strategic focus, I mean, really we're looking at application focus. That's some of the products I'll be talking about today. They focus on very specific applications for me, IIoT, data acquisition, and flow measurement applications. But we really are well known for our customer experience. We are constantly trying to provide a good level of tech support. That is one of the things that has helped us over the years. And there we go. And so as we talk about some of our key applications, we've got 4 main key applications, and I'll be talking about 2 of them today. Automated material handling is something that we do with a lot of our wireless products. Everything from production facilities to AGVs, automatic guided vehicles for warehouse applications. We've got some specialized technology that we've worked on as far as being able to operate with Rockwell control systems. And so we've done a lot of work there. Modernization, we do modernization for legacy PLC5s, SLC 500s, things like that. We've got a full suite of modernization products, and feel free to go back and look at the video. We've added a couple since 2015. And then remote connectivity is one of the things. I mean, as you really talk about IIoT, remote connectivity is one of the areas that we've gone ahead and focused on for IIoT applications. And then integrated flow computing, being able to pull measurement related applications into a Rockwell processor. And so for IIoT, really what we talk about for our IIoT solution is ProSoft Connect. ProSoft Connect is a cloud-based software application that allows everything from remote access, data monitoring. We've got some support for persistent data networks, and then we'll be expanding out on some of our data visualization applications. But really, where we started out was secure remote access and being able to troubleshoot devices from all over the place. If you've got guys in the field or you're building equipment, sending to different locations, being able to dispatch people onto site all the time is not economically convenient or economical or convenient. And so being able to access devices remotely is a big thing. Being able to monitor some of that information and be able to store that information to find if you've got a failure of a device on site, if you want to first fault detection and figure out what preceded that failure, having a lot of information available allows you to make better decisions as to those things, and that's what we'll be talking about with our data logger product. Persistent data network is something that we just recently introduced about 6 months ago, I believe. And what this allows you to do is to set up telemetry networks where you're utilizing things such as cellular-based technology to pass information back and forth between devices. And so where we see this as being very advantageous for some of our customers is, say you've got a particular asset, or if you're an oil and gas producer, you pick up a new field. It may be months before you can get all the the different wireless technology out there, get it integrated into your infrastructure. Being able to set up a persistent data network very quickly, very easily, and pass that information over allows you to make those real-time decisions without having to set up all your towers and your wireless communication, utilizing the cellular technology that's built in today. So when we talk about secure remote applications, really ProSoft Connect is the foundation or the building block behind it. And some of the applications that we look at are things like well pad automation, food and beverage, modernization, water, wastewater, and broadcast type applications. So being able to monitor assets that are spread out in different locations, as well as mining type applications. The key thing, the biggest question that we always get with secure remote access is security. That is a huge concern for everybody that's offering secure remote access, and rightfully so. I mean, if you look at some of the data hacks, I believe it was the Target data hack that was opened up by a remote access device that was left on an HVAC network, and so that opened up a big door, and for companies it causes a huge expense. So we've implemented some unique technology. We've got a feature that's called virtual lockout tagout, VLOTO, and that allows for a dynamic authorization in the product. By only supporting outbound connections, it goes ahead and provides a level of security. We've got two-factor authentication that's built into the product, so you can use two-factor authentication, either an email or an app base where you have to have the encryption key. One-time use tunnel credentials, and one of the things that, as we looked at some of the other secure or remote access products out on the market, really one of the biggest areas of vulnerability was in the software packages to remotely access devices. 90% of all data hacks that come through are not taking advantage of zero-day vulnerabilities. They're taking advantage of known vulnerabilities. And users are targeting those and hoping that people don't update their software on their computer to go ahead and so that's what they're taking advantage of. And so with us, what we're utilizing is built-in Windows VPN networks. And so as you get the annoying update your software on a Friday afternoon, your IT department's automatically pushing those updates to your computer. That's all based off the Windows software, but it's patching your network. It's helping build a secure network right there. And we take advantage of the same technology that's built into your PC for VPN connections. So there's no third-party software to install. And that thus gives you a certain level of security right there. There's other features in there, such as HTTPS, SSTP, 256 AES encryption, and a bunch of other security features. So, I mean, really, when you talk about anything secure remote access in the cloud, security is really the biggest concern for those things. And we've done a pretty good job of being able to address a lot of those security needs. The two-factor authentication, like I mentioned, it's a token-based two-factor authentication, requires a login. You can go ahead and configure it through a QR code scan, and it's more secure than SMS-based two-factor authentication. One of the things that the security groups that have published information, SMS is really not a secure way of doing two-factor authentication. It's a very common way of doing it, but it's not the most secure as those things can be. I mean, I've gotten cell phone calls from my own cell phone number, and so it's very easy to go ahead and manipulate some of that information. So yeah, you log into a website, you go ahead and you can pull up a QR code, and it goes ahead and gives you it's utilizing Google Authenticator for the two-factor authentication. So as far as the tunnel and being able to remotely access devices, we've got a couple of different plans there. We've got a standard plan, which basically allows you a single connection to each device. But in some organizations, sometimes you need additional people working on a project at the same time. So say, for instance, this is a SCID application. You've got one guy that's going to need to be working on the PLC code. Another guy may need to be programming or getting a VFD set up. Another guy may be programming a panel view. So in instances like that, you may want to require multiple users to go through the same device. And that's where we've got what we refer to as our power user plan. And so that allows remote access to multiple devices. One of the nice features with how we've done our remote access solution is if you're a Rockwell user, your native tools are all supported within, so we support a layer 2 connection. And so it's essentially the same thing as if you plugged into a switch on that device, but through a remote access. Whereas with some of the other remote access products, you may have to set up routing tables to route from one IP address to service port 44818, which is what Rockwell uses for all the Ethernet IP communications. Since we're a layer 2 device, you don't have to set up those routing tables. You go in, make your tunnel connection, you browse with RS links, and next thing you know, it's going to show you with Ethernet devices, it's going to show you all your devices out there. So you don't have to keep track of IP addresses on the device. You're making a secure tunnel connection, and then your native tools that you're used to using if you were physically in the plant and plugging into an Ethernet switch are all available to you right there. VLOTOs are dynamic authorization. And so this allows you to set remote access, and it's basically we call it virtual lockout tagout because it's similar to a lockout tagout procedure. Somebody has to request access from either one user or multiple users. Anybody in that plant or that's on the authorized user list has the ability to deny privilege at any time. So even if somebody went ahead and talked to or sent an email out and one person granted access, the VLOTO authorization will allow them to somebody else to, if they need to now take that machine down or they need to go ahead and deny that remote access, that person can then go ahead and deny it, and that instantly revokes that access right there. So it provides just another layer of security to make sure that everybody's on the same page as they're going and allowing remote access to these devices. And then authorized approvers do not necessarily have to be ProSoft Connect users. So we've got the cloud-based application. Authorized users could be a plant manager. It could be an IT person. It could be anybody that the account or manager decides needs to have the authorization approval on these applications. So. Easy Bridge is what we call the technology or the ability to do the remote access connections, and so that's essentially what I mentioned with the layer 2 connection. So your tools such as Studio 5000, RS Links, the Factory Talk View, all of those same tools are going to be able to make a remote connection. And so on your Windows-based PC, you're going to make a standard Windows VPN connection. That's going to go through your firewall over to your ProSoft Connect. Your ProSoft Connect device is going to go through a cellular network or a wired Ethernet network. And it basically is going to operate as a device connected to this switch. So it gives you a connection just like you went ahead and took that computer and plugged it into this switch right here, and gives you complete data acquisition or the ability to remotely monitor to go ahead and pull those devices through. I did mention that there's a couple of different power user plans. So as users are increasing the amount of data that they're using or need more concurrent connections to an individual device, you can go ahead and set that up through the ProSoft Connect and the different power user plans right there. You can invite existing ProSoft Connect users. You can control access to various projects, and then you've got single user, multiple organizations that are supported in there as well. So ProSoft PDN is what we call, this is our persistent data network. That was what I mentioned as far as being able to set up remote applications. And so what it does is it utilizes the same ProSoft Connect cloud service. And then you've got through cellular devices, it can be a combination of cellular or Ethernet-based devices. You can set up these virtual networks. And so that allows you to, it takes advantage of all your ProSoft Connect, all the security features that you have in there. But it also goes ahead and keeps a tunnel that's set up so that you can pass data through multiple devices. So like I mentioned, customers that may have assets that they obtain from another company or something like that, they need to quickly be able to bring that information into their business systems. They can go ahead and you can literally get these networks set up in 5 minutes. I mean, really, if it's a cellular-based module, your path study is going out with a cell phone and looking, okay, I've got 3 bars on AT&T. All right, let me go buy an AT&T activation. Or I've got 4 bars on Verizon. Let me go ahead and set it up with Verizon activation. Or if you've already got an existing Ethernet connection, we've got a wired-based product that would fit in there. But this persistent data network allows you to go ahead and set up applications similar to, I mean, we're actually seeing it right now for a lot of 900 megahertz applications. As that technology's gotten older, as the spectrum has gotten more congested on 900 megahertz, you're not seeing more allocation of resources in that particular spectrum, but your cellular technology is expanding all the time. I mean, we're 4G now, 5G is coming or is being deployed in certain areas. And so the cellular-based technology allows you to get a lot of data throughput and bring that information back into your system. And really with IIoT applications, it really is about getting data from the devices so that you can make intelligent decisions for your business and your operations. So for PDN applications, authorized external user access, so you do have the same capability for VLOTO and secure remote access for troubleshooting. So some of those same functionalities that are as a persistent data network, you still can take advantage of being able to remote into devices. So that's just another added benefit right there. Data logging and storage capacity, it's an always-on connection, and then once being able to get access to that information allows you to tie some of your business analytics to that to make more intelligent decisions there. And so where we see it, water and wastewater applications, oil and gas, some industrial applications where you're doing machine monitoring or connectivity for smart instruments. And then we've had some non-traditional applications such as like vendor managed inventory for vending machines. We actually have facilities we have an application story on our website where somebody's using it for portable bathrooms. So to know when to dispatch somebody out on site to go ahead and take care of that. So. And then this is just an example of like a small oil and gas operation that may have assets spread out through different areas. and they can go ahead and, like I mentioned, we can combine wired connections through a traditional Ethernet application or wireless through like our ICX35. So you can build out these PDN networks with various products, whether it's wired or wireless, and make the best combination for what you need. And it's ideal for floating installations or new assets that are acquired that need to be quickly brought online, and allows you to get to that information very quickly. Any questions on remote access, cloud? All right. So yeah, another thing that when we talk about IIoT applications and some of the capabilities with some of our product line is one of the things we talk about is data logging. Data logging is something that, I mean, as companies are trying to make more intelligent decisions, access to that data is critical. Sometimes you don't necessarily have the ability to, that information's not easy to get access to. And so when we look at being able to get access to that data to make better decisions, what we've created is a data logging product, which is just a low-end data logger. It's not necessarily a historian where it's tying into OSI Pi. Rockwell has solutions for that, and they work very well. But we've got various devices or customers out there that needed to get information from a field device and be able to access that information. And so sometimes those devices are on Ethernet IP or DF1, Modbus, and you need to be able to store a lot of information with very with good precision and get that information easily. So some of the benefits for something like this is being able to connect equipment all over the world to reduce travel costs and gain operation efficiency. We've actually used this product for our tech support group. We've had an issue where we couldn't quite figure out what was going on with a customer. We sent them one of our data loggers. They set it up to log a bunch of information, and we were able to capture what the issue was with the PLC code that they were using and troubleshoot it and figure it out. So that worked out a lot better than sending an engineer on site for, especially this was a very remote site, and it was a very infrequent problem that would occur like once every 2 weeks. So rather than sending an engineer out on site and letting him camp there for 2 weeks, running a data log on his computer tied to the PLC, we just sent a little box over there. They said, hey, the problem occurred at 12:30 last night. They mailed it back to us. We looked at the data logs and, oh, okay. Yeah, this value got out of range here, created this issue, and so there you go. So it definitely gives the ability to gain access to that data and reduce travel costs, things like that. You've got the ability to just set a device on a network and continuously log data. So I've got another upstream oil and gas producer that whenever they put a well online, or before they even put it online, after they get it completed, they want to log tubing and casing pressure off of a couple instruments they want 1 second data for 60 days. So they go ahead and they throw one of these on the line. They grab the tubing and casing pressure off a Modbus interface. They go ahead and once they're done, they pull that device out, send it into their reservoir engineers. They grab the data off of it to look and see if it's performing how they want. So it automatically can log all that information for them. And so, yeah, like another use case would be continuously recording data from a pump jack. And once that information is logged in there, they can view it if they need to look at alarms, if they need to try and figure out what happened, if something occurred at that site. they can go ahead and look at that information later on and use that to make more intelligent decisions. Another use case for it is if you've got intermittent connections, network connections. So you may have a critical process that occasionally either going through a satellite link or through a wireless link. If you got inclement weather that you lose your wireless connection sometimes, or you may lose a satellite connection, you can go ahead and have a device that's standalone sitting on the network and just logging that information. So you don't necessarily lose it. You can go ahead and obtain that information. And for OEMs, this is kind of almost an example of what our support guys used it for, but OEMs could also use that. So they ship a product out to a site, and as they want to go ahead and make optimization to a product, they can go ahead and log that information locally on the product itself. And I mean, we do talk a lot about remote access and IIoT, and that's definitely what is enabling businesses to make more intelligent decisions. But sometimes putting remote access on a piece of equipment, people don't necessarily like that. And so by being able to log the information locally on a device with a hardware level appliance, that's something that if you send a machine over to a particular location, you've got that data logging built right in there. You can have a plant manager or maintenance person upload that data for you, send it over. It's no longer remote access. It's just a data file that they're sending you. But you can continuously, as a skid-based manufacturer, you can go ahead and continuously improve or make changes, improve your process to get better production out of the equipment that you've sent without having to, again, send somebody out on site. And this is the diagnosing intermittent faults. That's how our tech support team actually utilized it. And I mean, yeah, I remember years ago when I was in support, we actually had to send a laptop to a customer at one point. And because they weren't gonna, the maintenance guy wasn't gonna have his laptop sitting there 24/7 while we were trying to figure out and log information. And actually, I think we tried logging information at one point and it overloaded the buffer, rebooted the laptop, and we lost all the data. So being able to send just a hardware level appliance out there that can log all this information and can help diagnose those faults or those issues that just kind of randomly appear out of nowhere. And they always randomly appear at like 12 o'clock or 2 o'clock in the morning, so it just never fails. The data logging can be downloaded to a CSV file, and so and then you can automatically program a data log file via Logix 5000 controller. The data can be stored directly in the module memory and can be overwritten when the memory's full. And the data can be logged through a delta change, heartbeat, or tag trigger. So that allows you to optimize the amount of records that you can go ahead and set up. Time-stamped information, and when we talk about data, the module can store up to 16 million time-stamped event records from an Ethernet IP network. So we've got a little, I think we've got a little spreadsheet that figures out how many tags that is at what resolution and stuff. But I mean, a small little box can log up to 16 million records. Gives you quite a bit of capability. I've got some applications that they're using it that we're logging, I think, 3 years worth of information at, I think that's 1 second resolution or something like that. But other applications, you can log 100 millisecond data for 6 months. So it does give you a lot of capability right there. And you can go ahead and log up to 3 individual devices. So say you had a drive, you had a Control Logix processor. You can go ahead and log information from both of those devices and store up to 200 tags that can be configured. So Any questions on that?
How does the user get the data out of the data log?
So
Is it a SD card or something?
it's stored as a CSV file in the module. And then we've got a PLX50 configuration utility that the user just connects to and can upload the file directly from the config utility.
Some kind of reporting tool?
Yeah, there's some visualization that you can do, but it's basically the majority, it's mainly a CSV file. And so you can pull that into Excel, you can pull that into other business analytic tools. And that's where, as I mentioned, it's not a true historian-based product. I mean, Rockwell's got the historian module. It does a really good job on that for Pi and getting that information into an analytics package. This is more of a low-end data logger that will allow you to get access to a lot of information. So, but yeah, it's stored in a CSV file format. Yep.
In addition, you said that you could also take that, instead of doing the CSV, you could just take that data and dump it into the controller as well. Is that correct? Programmatically?
So you can trigger data logs to be, so mainly the module is reading from the controller via Ethernet IP, but you can trigger a log off of the PLC. So if some event occurred in the PLC and you want to keep track of that data, you can tell the device to cut a record, and that will go ahead and do that as well. So.
Can you set up automatic emails of the data, just of the file, say every 2 weeks, or if there's an event?
Not, yeah, not. So we're right now working on some enhancements to the data logger product. I believe that might be as part of our next gen. But right now it doesn't have a way to do like automatic email trigger and stuff like that. But I can check on that and follow up with you on it. So
Just a note for those in the room, we do actually have the data logger on the wall back there. So after the session, you can take a look at it.
Yep. Well, cool. All right. And last but not least, measurement applications with integrated oil and gas. How many of you guys do oil and gas work operations? Okay. All right, great. So yeah, this is a product that we've actually had a oil and gas flow computer since 1993. We did the first one on a PLC-5 platform many years ago. Yep, and so over the last couple of years, we've really focused on being able to enhance that product offering. We had some pockets of installations in Canada and Latin America for the old module, some applications in the US, but we really, over the last couple of years, have looked at how to tailor this product to fit some of the needs of North American producers. And one of the reasons that we saw a need for that was we were working with a lot of installations such as this, where you had standalone flow computers, you had control Logix or compact Logix out there. Most of the time, and the reason we know that these were tied together is there was usually a Modbus TCP IP module sitting right there. And so we were talking with customers that were programming our Modbus TCP IP modules to talk to various flow computers over an Ethernet network. And so it started getting the wheels turning of, well, hey, we've got a flow computer module, and okay, why are they using that instead of, and it was really some of the functionality that we didn't have in there that was needed. One of the nice benefits of something like this type of application for customers was they were able to start taking advantage of distributed I/O, which was natively supported within the Rockwell architecture. So on something like a central tank battery, you could go ahead and place distributed I/O blocks out near your separators, out near your tank batteries, out at the wellhead or the pump jacks. You could go ahead and place the I/O local to those devices. And so as equipment was getting set up on site, you had pre-wired control cabinets, such as on a separator that had all your instrumentation already wired in. They could put that on site, and really at that point your power and Ethernet is really the only thing you had to do to bring this information back to the controller. So, so that was a lot of applications we were seeing with flow computers and Rockwell equipment out on site. During one of the last downturn, we started seeing customers really trying to right-size the operation, and a lot of times that meant taking out the Rockwell control architecture, and then these flow computers, some of the flow computers could do some automation. So that you could program instructions in there to do some rudimentary control on the site. Weren't able to take advantage of things such as the distributed I/O, so now you're having to home run wires all the way back to your control cabinet. Not as clean installation or as easy to work with as some of the previous slide, but really the primary purpose or the main thing that needed to be done was the measurement of gas and oil at that site. And so as you had to take a look at what platform they were able to use, it was really the standalone flow computers that had to be used because this was providing custody, transfer, allocation-based measurement on the site. So, so some of those traditional flow computers were devices from Emerson, ABB Total Flow, SCADA pack units. And so it was typical to see on a lot of installations, one device for measurement, another one for control and automation. As we started looking at, or as customers were starting to utilize just flow computers out there, your I/O counts were limited, your number of metering measurement runs was limited, and so a lot of times it required them putting additional devices on site. And so one customer I worked with actually had 5 competitive products on site to, I think it was a 24 well pad that they were doing. And so they had to have 5 different flow computers on site to go ahead and get all the information, do all the automation. That also required additional networking back and forth between those devices. So you had to, it was a little bit more configuration. And then in addition to all the additional hardware, there was also software and licensing costs that had to be associated with those. So with our in-chassis flow computer, what this allows us to do is it allows us to basically perform the measurement-related functions of those standalone flow computers in a coprocessor module that fits directly into the Rockwell backplane. That still allows you to provide your custody, transfer, and your allocation-based measurement. And then it also still allows you to be able to take advantage of that distributed I/O platform. So back to that first slide that we were looking at, this now encompasses the standalone flow computers all into a Rockwell platform. Now the other thing that, as we talk about measurement related applications, a lot of times that measurement related data is, it's not factory talk view that they're using for SCADA. There's things such as Signet and AutoSol that are being used for polling engines. And so we've actually, within our measurement solution, we've had to provide connectors back to the one that we've worked on the most was probably the Signet. And we provide a DTF file, which is essentially like similar to an EDS file in the Rockwell world, but it basically tells Signet how to pull all the measurement related data out of our flow computer. So when we look at some of the specific requirements for oil and gas applications, in addition to just the measurement aspect of it, data archiving is a huge thing. The API requires 35 days worth of data archiving for both hourly and daily records. We support 60 days worth of hourly records. And then as far as a daily record, we support just under 4 years worth of daily records, so 1,440 records. The other thing is you have to keep track of things such as an audit trail, an event log. You have to have the ability to lock out changes. So from an audit trail perspective, that could be anything from changing an orifice plate size to changing a meter factor to changing gas analysis data. From an event log perspective, that could be anything from power cycle at the site. So even though we're tied into the PLC, the measurement module will actually keep track of if that PLC loses power and create an audit trail or an event log, just as it was a standalone flow computer. And then for locking out changes, we've got different ways of doing that as far as password protection, which can provide access to certain parameters, as well as being able to, there's a physical switch on the module that you can go ahead and lock that switch, wire seal it, and then somebody can go ahead and put a tamper seal on there. And that gives you a physical indication as to whether or not there's any changes there. And then lastly, I mentioned interface to SCADA. And so for SCADA applications, it's typically Modbus or Enron Modbus. And so we tie in with measurement data in a Modbus or an Enron Modbus network. So there's a full list of measurement compliance standards. The main ones being AGA 3, 7, 8, as well as API chapter 21.1 and 21.2. Those are the key ones that I see our customers requiring for their applications. So some of the applications that we've done is things such as a LAC skid, pipeline monitoring, gas plant, and multi-well pad applications are some of the key areas that we've focused in on. LAC skids, we've done several installations of those with the compact Logix L24, L27 processor. And so that's the small modular level processor. It's got some built-in binary inputs. It's got a built-in analog, high-speed counter, power supply. And so for a small LAC application, that becomes a very economical way of doing a LAC skid. And then the nice part about that is if you start off with something like that, you've got code in Studio 5000. So if you need to migrate over to a multi-well pad application on a larger compact Logix processor, you can reutilize some of that code, move it over to a multi-well pad application. And then expandability is another thing I'll talk about in just a minute. So, but when we look at some of the multi-well pad sites, really, as we looked at some of these sites, the IO counts was exceeding some of the RTU capability. Multiple RTUs, if you remember that drawing earlier, it showed 3 different flow computers. I had a customer that was utilizing 5 different flow computers. It created revision control issues. I mean, they would have an update of the code. They'd have to go ahead and update that in multiple devices. Sometimes it would get updated in one device, not in another. Then it would cause additional issues there. So being able to consolidate all your control and measurement in one device gives you one source to if you need to make changes. One of the things that we saw with some of these multi-well pad sites, as they grew in complexity, a lot of the RTUs and standalone flow computers were being used on applications that were solar powered and didn't have necessarily grid or generator power. But as the well pad count on some of these applications increased, you normally have grid or generator power. You also can have control houses. You have high bandwidth communications, which gives all the infrastructure related stuff that allows people to want to take advantage of that and get access to more of their data from their operations. And as I mentioned before, the scalability within the Rockwell line really allows customers to go ahead and you can start slow on something like an L24 processor. As your automation needs at your site increase, you can move into the L30, 33, or 36 line, now 38. As the automation needs still increase, you can move up to control Logix with the L8 processors. And it really allows you to continue to reuse that code. And it gives you an expandable platform that instead of dropping in, as you fill up one platform, instead of dropping in standalone flow computers and RTUs, you're now increasing the amount of memory that you're using on your Logix processor, adding additional I/O modules in there, and then duplicating your code. So distributed I/O, and then also you've got numerous options for communications networks. So customers are using HART for doing water measurement to mag meters. They're doing Modbus to multivariable transmitters. They're doing 4 to 20 or high-speed counter signals for your pressure, temperature, your Coriolis meters that are doing oil measurement. So you've got all those options that are built into the Logix-based platform. One of our customers referred to as a cost-effective, industry-shifting, scalable marriage between automation and measurement. And so one of the things, since it is a coprocessor that fits in the backplane, one of the things that we wanted to do is, one of the pain points on some of the standalone flow computers and RTUs was licensing. You get a device that fails and somebody has to swap it out. There's a license key associated with liquid measurement runs or the number of measurement runs. With our module being a coprocessor, it fits in the backplane. There's no additional licensing fee. So any combination of liquid, gas, that's all built into the module. The module supports 16 meter runs on control Logix, 12 meter runs on compact Logix, and it's any combination that you choose. So you can do all 16 liquid measurement runs, measuring oil. You can do all 16 as gas, and there's no additional licensing fee. The other thing that we did is, in working with measurement teams, they don't want everybody to be a PLC programmer to come out and do things like change an orifice plate size, to go ahead and enter new gas analysis data, to calibrate transmitters. So we've got an EAFC manager software, which is a free download. And so this allows your instrumentation, your I&E techs to go out there, perform the functions that they need to without having to become PLC programmers. And then lastly, the engineer wants scale and reuse. I mean, the Rockwell processor line is a very scalable platform that will allow you to pick what solution is best for your operation. And if you exceed the amount of memory that's being used on that processor, unless you're using an L85 processor, you can step up to the next one. If you're on L85, and you exceed that 40 meg of memory that it allows, you might, that's a big application. So yeah, as I mentioned, we have control and compact Logix versions. Really the only difference between the two products right now is compact Logix is 12 meter runs per card. Control Logix is 16. And the nice part about it, just as it's a scalable solution, it's a coprocessor. So if you need more than 16 meter runs, put another Control Logix card in there. If you need more than that, another one. We've built out reference architectures with up to 6 Control Logix modules, which gave you a total of, I think that was 96 meter runs right there. And even at that, we're still not filling up all the memory in the processor. There's still plenty of code for your control narrative. So no additional licensing fees, secure data archiving. All the data is archived directly on the module. And so there's non-volatile memory on the module. You're not, that information can be passed into the PLC, But if you lose power at that site, you're not going to lose any of that data that's securely stored on the module. And then, as I mentioned, a configuration software, which allows your measurement guys to go in and perform the functions that they need, such as configuring the meter runs, updating gas analysis. And then we also support being able to export different data. So your measurement data can be exported in FlowCal CFX file format, either version 5, 7, or 8, or a standard CSV file format. And then for communication back to a SCADA host such as Signet, it's done utilizing Modbus TCP IP. As we started working with them, we asked them what was the best way to get information to them. And they said, Enron Modbus. And we're like, there's not a better way to do it than that. They said, that's the way most other people are doing it, so just do it the same way. And so we're doing Enron Modbus to pass alarm, event, and archive historical data out to Signet. And then with AutoSol, they actually worked on a custom Modbus interface with us, so we can pass data back to AutoSol. And that allows both Signet and AutoSol to do CFX publishing or PGAS publishing for exporting that information to FlowCal or PGAS. So yeah, the top benefits: license-free model, no licensing for oil, gas, water. It's modern PAC architecture that can be scaled to the needs. If you need to add more metering points, add an additional AFC module. Configuration software, which allows you to do your setup and configuration for your measurement groups. Distributed I/O, where you can take advantage of pre-wired control cabinets, and at that point you're just delivering equipment on site, power Ethernet cable, and tie that back to your control architecture, and everything's all set up. And really, I mean, the sweet spot with this type of solution comes in as the greater the measurement on an individual site, the better the cost savings. I mean, if you're not going to look at a Rockwell-based and ProSoft measurement solution for a single well pad operation. There's plenty of RTUs out there that can do a single well pad operation, but as you're looking at larger installations that may need either the processing capability of a Logix-based system in addition to measurement, or a larger installation with more well counts, more measurement points. One of the things that we've seen is as customers, before customers were just measuring oil and gas. And that was because they ran out of meter runs to measure water. In some installations, I mean, the cost of transporting water off their site or processing it, they now want to measure water the same way that they're measuring oil and gas. And so being able to add an additional card in there that provides API compatible logging for water measurement is a nice benefit for some customers as well. And so yeah, need more measuring points, add a new AFC card. And so that was really about it. I was gonna touch on modernization solutions if we had time, but we don't have time. And you guys have the link to the video. Oh yeah, absolutely. Yep. Yeah, I mean, really when we talk about like IIoT, being able to bring that data information in, modernization allows people to get old equipment into newer architectures to take advantage of it. So, yep.
For any questions online, feel free to chat in on the chat tool, Terry.
Is it just for the LE? L7?
It will work with L7. It'll still work with L6s too. We actually create our default add-on instructions in version 16 of Logix because it's easier to port forward than backwards. But yeah, once you go up to an L8 controller though, you can't go backwards. So I learned that the hard way. So, but no, we can do L8. I just mentioned L8 because that's our newest, most powerful. And when they went with the L8 line, if you look at comparable memory in an L71 and L81, they increased the amount of memory there. So, but yeah, 40 meg on an L85. I've built just a test application with like 140 wells or something like that. And I think I still had, for the controller, I think I still had like 38 meg of memory left. So yeah, I don't know what the limit would be on an L8. The limit's really going to be, what do you feel comfortable installing on a single site operated by a single controller? So then you get into redundancy.
The only reason I really asked, because all of our customers know.
Oh, okay. Yep. Yeah, L6s, 7s.
They went to the select.
Okay. Good. All right.
Okay. So no questions online, so we'll do a last call in here. If not, these guys will be around for a little bit. You're more welcome to stay and chat and discuss. So we'll wrap it up. I want to thank Eric and Joe and ProSoft for coming in town for this presentation today. Appreciate that.
Thank you.
And
Thanks,
thank you guys
everybody.
for coming as well. We'll shut it down. Thanks.